In this video, we will be exploring how changes in the distribution of data affect the mean, median, and standard deviation in a data set. In this illustration, the data is distributed symmetrically. When this is the case, the mean and the median will be equal to each other. They are measures of center, and we often want to measure where the peak falls in a set of data. Here, we are looking at a real set of data. The distribution is symmetric and could be folded in half. The mean and the median are almost equal, but not quite, because we are looking at real data, which likely produces a slight discrepancy. Suppose we add outliers or very large amounts to the data. One example might be income. Now you can see the majority of the data have a symmetric distribution, but now there are outliers on the histogram. You can see that the mean is now inflated. It is larger than the median. The mean is now pulled toward the outliers. Note that the median only changes slightly. The median does not move much when outlier is added to the data set. The third scenario we want to look at is skewed data. This histogram illustrates skewed data. You can see the peak at the left side, but instead of a symmetrical shape with outliers, you have what's called a long tail here, skewed to the right. The measure of center, which is our concern, measures the peak. In a skewed distribution, the median will still be close to the peak, while the mean is pulled to the skew. You can see that the mean is again inflated. It is larger than the median. The mean is larger in the direction of the tail. The median is not drastically affected by the long tail. Again, it is the better representation of the peak of the distribution.